Hello everyone. So today we are going to talk about number patterns, and we're going to start with a concept called square numbers. So as you can see, I have drawn three diagrams. What I've attempted to draw are dots arranged to form a square. Okay, so I want to try to analyze these diagrams and see if we can make sense of them. So beneath each diagram, I have written what we call in math language an expression. S2 equals 4, S3 equals 9, and S4 equals 16. I want to try to make sense of what this expression is trying to say to us. So we've got these terms that we call in math that have S and a number. I want to figure out, what does that number mean? Well, I think it's pretty quick to see. My hunch is that this number 2 refers to the number of rows, right? And it's a square, so it could also be the number of columns, because with squares, obviously, the number of rows are the same as the number of columns. But so, we've got a square, so S square with 2 rows of dots. And again, I think it's pretty easy to see what this 4 represents. That's the total number of dots. Okay, so obviously I want to test and make sure that expression holds for the other diagrams. And sure enough, it does, right? This 3 represents the number of rows, or the number of columns. 3 rows, 3 columns. And we've got a total number of 9 dots. And of course, same with our third diagram, S4. Okay, cool. So we've figured out what how these expressions sort of describe the diagram that we're looking at. But now, what do we want to do with this? Well, like I said, what we're really looking at here are patterns. And so we want to figure out, well, what's the pattern here? How are these numbers growing? In other words, well, what if I wanted to figure out what S5 is, right? I mean, we could play the same game. I could make a diagram, try to make a square with, a row of 5 dots and 5 columns. And then I could count up all the dots. But we're dealing with squares. And I think, for most people, they would look at this and they would say, well, like, let's just go over here. If you want to figure out how many dots we have, and these are arranged in a square, well, you're just going to say there's 4 rows and there's 4 columns. So I'm just going to take 4 rows times 4 columns, and I'm going to get a total of 16 dots, right? And, that would hold true for every other diagram. So when we say, well, what is S5 going to equal, right? That's really what we're asking here. What does S5 equal? Rather than drawing out a bunch of dots, we're going to say, well, it's going to be 5 rows times 5 columns, and that's going to equal 25 total dots. So S5 should equal 25. And we can do that, without drawing out the diagram. Sorry, my S's and my 5s look pretty similar, don't they? Anyways. And we could take this concept and we could keep going and going. And as you guys have probably already realized, what we're doing is we're squaring numbers, right? 4 times 4 is the same as 4 squared. That's a different notation you might see in math. Whenever we multiply a number by itself, we can just put the little 2 above it, equals 16. And now, by the way, you might, if you didn't already know, you might know why they call that squaring, right? Because it's got this sort of concept to it. A lot of times in math, we take a number idea and we try to attach it to something geometric, and vice versa. Sometimes we take a geometric idea and we attach it to a numeric thing. Okay, well, this is great and all, but what can we do with this? And I think the goal to studying this, and sorry, I have these really crappy markers that I have to use water to wipe off. I think ultimately the real goal here, if we really want to understand how this pattern works, is we want to come up with what we call in math a formula, right? And all a formula says is that I can take any number and I can figure out how to represent it in this pattern. So if I were to write a formula for this, using the idea that we just learned, we could call this formula S sub n, right? N's just a variable. That's the number we're going to use, is always going to equal n squared, right? So we've seen here, when n is 2, it's going to equal 2 squared, which is, of course, 4. When n is 3, S sub 3 is going to equal 3 squared, which is 9, right? And with this formula, it's really powerful. Now, if I say, well, what is S sub 10? Again, I can just plug in a 10 for n and say, well, S sub 10 is 10 squared, which is 100. This tells me that my S sub 10 diagram is going to be a square diagram of 10 rows of dots, 10 columns of dots for a total of 100 dots. And I don't have to draw out this huge diagram in order to do so. Okay? So, hopefully this made a lot of sense. Most of you have seen square numbers, and so I don't think this should be too tricky, but we're going to make it tricky by introducing a slightly different concept of the same flavor here by talking about triangular numbers.